So you've built a regression model. It's predicting house prices or maybe sales numbers. How do you actually know if it's any good? It seems like a simple question, right? But the answer is a little more complicated than you might think. Imagine your model is off by $50,000. Is that a success or a failure? Well, the honest answer is, it depends. If you're predicting the price of a multi-million-dollar mansion, that's practically a rounding error. But if it's a small condo, that's a disaster. Context is everything. And that's our goal today. By the end of this, you're going to have a simple, practical toolkit for measuring your model's performance. You'll know exactly which tool to reach for and why. To figure out how good a model is, we first have to get really clear on how wrong it is. And every single evaluation metric, no matter how complex, starts with one fundamental building block. That block is called the residual. It's nothing fancy. It's just the gap between the true value and the value your model predicted. For every single data point, you get one residual. This raw error is the material we use to build everything else. And this is where the toolkit analogy really comes into play. All the different metrics just find clever ways to add up those residuals, but each one tells a slightly different story about your model's performance. Let's start with the two most common tools you'll find in any data scientist's kit. I like to call them the tape measure and the heavy hammer. First up is the tape measure, or mean absolute error, MAE. This one is as straightforward as it gets. It takes every error, ignores whether it's positive or negative, and just calculates the average. The final number tells you, on average, our model is off by this much. It's simple, honest, and treats every dollar of error exactly the same. Then you've got the heavy hammer. This is mean squared error, or MSE, and its cousin, root mean squared error, RMSE. This tool does not treat all errors equally. By squaring the residuals, it disproportionately punishes large mistakes. A single $100 error has a much bigger impact than two $50 errors. Okay, so we have our two main tools. Now let's get a little more technical and figure out when and why you'd use each one. This is where the trade-offs become really clear. MAE is fantastic because it's robust to outliers and super easy to explain. But mathematically, it has a sharp point at 0, which can be tricky for optimization algorithms. RMSE, on the other hand, gives you a smooth curve that's perfect for training models using things like gradient descent. So one isn't just better, they're suited for different jobs. Now, these error metrics tell us the magnitude of our mistakes. An RMSE of 50,000 might be amazing, or it might be terrible. We're still missing context. How do we know if our complex model is actually doing any better than a ridiculously simple guess? For that, we need a totally different kind of tool, one that gives us a relative score instead of an absolute error. Let's call this the report card. Its formal name is R-squared. R-squared answers a very specific question: how much better is our model than a naive baseline that just predicts the average value for every single data point? It gives you a percentage that tells you how much of the data's variance your model was able to explain. So if you get a value like this, it means your model is capturing 85% of the variation in the outcome. That's a huge improvement over just guessing the average every time. It's a grade on your model's report card. But there's a catch. R-squared can be gamed. If you keep adding more and more features to your model, even totally useless ones, the R-squared value will never go down. It can trick you into thinking a more complex model is better when it's actually just getting noisy. And that's exactly why we have adjusted R-squared. It's a smarter version that penalizes the model for adding features that don't actually improve its predictive power. It's the honest report card that prevents grade inflation. All right, so we've got our tape measure, our heavy hammer, and our report card. How do we choose the right one when we're working on a real-world project? The choice really comes down to what you care about most. If your data has some wild outliers and you don't want them to dominate the metric, the MAE is your friend. But if large errors are incredibly costly, think financial predictions, then you need the RMSE's heavy hammer. And when you have to explain the model's value to business stakeholders, R-squared is perfect. It gives them a simple percentage they can immediately understand. So let's bring this all together with the one idea you should take away from all this. These metrics are more than just a final score. They're diagnostic tools. They help you understand the specific ways your model is failing so you can actually go back and make it better. So always remember this: The best metric isn't the one with the lowest error or the highest score, it's the one that most closely aligns with the actual goals of your project.